Hello all, let's start your section 2.2. Section 2.2, we are covering trigonometric or trigonometric functions of non-acute angles, correct? The first thing that I want to cover is, and it's really important to know, is what is reference angle. First, we will talk about what reference angle. Reference angle. What is a reference angle? Let me put here for you the definitions, then I can explain. A reference angle, a reference angle for an angle theta, for an angle, let's name our angle theta, is the positive acute angle I will underline this part for you, positive acute angle made by the terminal side of angle theta. This is important, terminal side of angle theta and the x-axis Correct? This one is also important. What is a reference angle? Let's see it in a picture. If I have an angle theta, let me draw an angle theta in a standard position. Correct? This is the xy plane. This is your x-axis. And this is the y-axis. Let me draw, for example, this angle. This is the terminal side. This is the initial side, correct? This angle, I'll name it theta. What is the reference angle to the theta? Reference angle means there is an angle that's reference to this angle that the trigonometric functions of that angle is equal to this. That's the whole meaning. There is an angle that the trigonometric functions of that angle is the same as trigonometric function of angle theta. If you see the definition, they are saying that angle, if you name it theta prime, if I name it theta and a dash like this, I'll read it theta prime, is an angle that one side of that angle is the terminal side of angle theta. You see this side of theta prime is the terminal side of theta, and the second side is x-axis, but also this angle is positive. Your theta prime is positive. We call theta prime reference angle of theta. Theta prime is the reference angle for theta. Let me draw it in another quadrant for you, another example. For example, look at here. Again, xy plane. This is the x-axis. This is the y-axis. Let me draw an angle in a standard position. For example, this is the initial side, and this is the terminal side. And it's a positive angle. This one is theta. Now, the common mistake the students do is they immediately go this way. They say, oh, then this is the reference. No, actually not, because you have to focus on the terminal side, correct? You have to focus on this. One side of the theta prime should be the x-axis, which is this, and it's also a positive angle, correct? Which is this, correct? Then, if this is theta, the red one is theta, then the blue will be theta prime, reference angle to theta, correct? Or one more, I'll show you another one. This is your XY plane. For example, if I have this angle, initial side, and let's say this is the terminal side, correct? If this is theta, all of it from here to here, then theta prime will be this. Correct? This is your theta prime. This is quadrant 4. This is quadrant 3. And the first one was quadrant 2. Correct? Later I'll give you all of them, how to calculate. Now, the first example, let's do an example, then we discuss it more. Example number 1. Find the reference angle. Find the reference angle for an angle of 218 degree. They are asking you to find the reference angle for 218. First, let's see where is 218. Correct? This is X, this is Y. This should be the initial side in a standard position. Now, from here to here, when you come here, it's 180. If you go a little bit more here, somehow, I'm not measuring, this angle is 218. Then where is the reference angle? The reference angle, because you are in quadrant 2, should be this. The x-axis, and here, and a positive angle. This one. How much is this one, and how to calculate? You see here, later I'll give you notes. You follow those rules. Actually, those notes are the rules. If your angle is in quadrant 3, you subtract from your theta, which is 218, this quadrantal angle, which is 180, which gives you 38 degree. Actually, your theta prime is what? 38 degree. 38 degree is the reference angle for 218 degree. If your theta is 218 degree, your theta prime, which is the reference angle, is how much? 38 degree. Correct? I'll do one more example, then I'll give you the rules. Example number 2. Same instruction, find the reference angle for 1387 degree. Sometimes they give you like this, big angles. What to do now? The first step that you want to do is you want to find the coterminal angle. You already know how to find the coterminal angle. You want to find the coterminal angle for what? Which should be between 0 and 360, greater than 0, less than 360 degree. You find that angle for 1387. To do that, we have to find a way how many times I should subtract 360 from 1387 degree to get that angle. The easy way is do this. Divide 1387 by 360. It gives you a decimal, 3.9. Don't worry about the decimal part. This part is important, the whole part, 3. It means if you multiply 3 with 360 and subtract that from 1387, let me write down 1387 degree minus 3 times 360, it gives you the coterminal angle. And if you do this operation, you will see that it's 307. Correct? If you say no, let's do it. 1387 degree minus 3 times 360. 3 times 0 gives you 0. 3 times 6 gives you 18. 3 times 3 is 9. 1080. And if you subtract, you end up with 307, right? Now, what we do here, after this step, we draw this angle, or even without drawing, if you see, if you subtract this, which is 3 from 360, if you subtract 307, definitely it gives you a small angle, which is 53 degree. This 53 degree is actually a reference angle to 1387 degree. It means if your theta is 1387 degree, your theta prime is 53 degree. I know it looks right now crazy for you why I subtract, but soon I'll give you rules. If you don't like that explanation, look at here. I'll draw 307 degree. 307, 270, here somewhere will be 307. Correct? This is 307. The rest is 53, because if you add 53 with 307, it gives you 360. That's why it's a reference angle. Correct? Now, let's put some concrete rules. I want you to have this on the, if it's a test day, on the note card, and actually you have to memorize it or learn it. Correct? I'll draw 4 quadrants for you. First, I'll start with quadrant 1. If your angle is in quadrant 1, correct? So I give you some general rules. This is x, This is y. If your given angle, which is theta, is in quadrant 1, an acute angle like this. This is theta. In quadrant 1, this is quadrant 1, right? Q1. In quadrant 1, always your theta is equal to theta prime. It means the reference angle is the same. If the red one is theta, the blue one is theta prime. Remember this. Quadrant 1, theta is equal theta prime. Quadrant 2, if your angle theta ends in quadrant 2 or lies in quadrant 2, correct? X-axis, y-axis, I will draw theta in a standard position. This is the initial side. This is the terminal side. This is your theta, right? Where is theta prime? Theta prime is here. This is your theta prime. How I can find? I give you a rule here. If your angle lies in quadrant number 2, then do this. Your theta prime always equals these relations that I'm writing for you, or these equations are really important. I used it in 2 examples before explaining, right? Theta prime equals, always subtract from 180 what? Your theta. It gives you your theta prime. Because the total is 180, right? I'll do examples later for all of them. Quadrant 3. If theta lies on quadrant 3, this is x, this is y. I'll draw theta for you. This is the initial side. This is the terminal side. This is theta. The angle lies in which quadrant? Quadrant 3. What to do? What is the relation? What to do? How to find the theta prime? Your theta prime equals theta minus 180. Why? Because you see, this is your angle. This is your theta prime actually. If you subtract from theta 180, the rest will be your theta prime, which is here. Correct? Quadrant 4. If theta lies in quadrant 4, this is x, y-axis. I'll draw again angle theta in a standard position. Initial side, terminal side. Correct? This is your theta. How to find theta prime? Theta prime actually equals 360. You see, from full round, if you subtract theta, the rest is theta prime. It means here, this blue, this positive angle, this is your theta prime. If you remember this 4 quadrant, you can solve any given problem using reference angles, correct? The problems that you are dealing with reference angles. You can do it easily. Let's do an example. Let's practice with this. Then we will do some more kind of lecture. Example. Change the color in black. Find exact values find exact values of the 6 trig functions for 210 degree. You see, we don't know what is the trig functions for 210 degree, but I can see 210 is greater than 180, but it's less than 270, right? It means 210 is in which quadrant? 210 is in quadrant number 3, right? At least you can think this much, that 210 ends up in quadrant 3. Then my theta prime is actually equals, what was the rule? Theta minus 180. It means here your theta prime equals theta, which is 210 minus 180. It means your reference angle is what? 30 degree. Okay, in your book, they draw the picture. They again use X, Y, R. But remember the other day, we learned and we already have a table. We know what are the 6 trig functions for 30 degree. The only thing, focus here. I will use the 6 trigonometric functions for 30 degree. Let me list them all, because you should have the table printed in a piece of paper or memorize it. If not, do it now, correct? I will help you in this example. I can write this way now. Sine of 210 degree equals to the sine of its reference angle, which is 30 degree, equals sine of 30 degree is 1/2. Correct? Sine of 30 degree is 1/2. But 200, why 1/2? Because 30 degree is in quadrant 1, right? All trigonometric functions in quadrant 1 is positive. But your 210 lies in quadrant 3. If 210 lies in quadrant 3, then definitely I'll do this. I'll put a negative here. Sine of 210 is actually negative 1/2. Correct? Because I'm in quadrant 3. Remember this thing? I will draw it, but I'll erase it back. Here x positive, y positive. Here x, Here your x was negative, y positive. Here negative, negative. Here positive, negative, right? This is your xy. If you are in this quadrant and you are dealing with sine, and you know sine is y, correct? If y is negative, definitely sine is negative. Correct? That's why I changed this sign. Correct? Hopefully you understand it this way, because we are not drawing angles all the time. We use the tricks or the rules that we already learned. Now, cosine of 210 degree should be equal to the cosine of 30 degree with a change of sign if it's necessary. Cosine of 30 degree is radical 3 over 2. Correct? Again, because 210 is in quadrant 3, x is negative, then this is also negative. Negative radical 3 over 2. tangent of 210 equals to the tangent of 30 degree, which is radical 3 over 3, or a square root of 3 over 3. Correct? It will be positive because tangent is positive in quadrant 3, remember? Because it will be negative over negative, it gives you positive, correct? Hopefully, you review the other lectures that we already did, correct? Now, secant of 210 equals to the secant of 30 degree. Of course, we will fix the sign, correct? Secant of 30 degree is 2 radical 3 over 3. 2 radical 3 over what? 3. You are in quadrant 3. Secant is the reciprocal of cosine. Of course, it's also negative, correct? Cosecant of 210 degree is equal to the cosecant of 30 degree, which is 2, correct? Cosecant is the reciprocal of sine. If sine is negative, then cosecant is also negative. And last, cotangent. Cotangent, sorry. Why I put an A here? Cotangent of 210 degree equals to the cotangent of 30 degree, which is radical 3. Cotangent is the reciprocal of tangent. If tangent is positive, then cotangent is also positive. Correct? Now, I write here some steps for you when you are finding trigonometric function for any non-quadrilateral angles. Let me put that topic here. Finding trig function values or functions or values, function values, which way you write, for any non-quadrantal angle theta. Any non-quadrantal angle theta, if I give you that, follow the steps, you can find all 6 trig function for that, correct? I will write the steps here. It's in your book also. The steps are on page, hopefully, see if they give you the steps. The steps are on page 177, but anyway, I'll do a shortcut here for you. You can see it in this lecture also. Step 1. What you do in step 1. If theta is greater than 360 or if theta is less than 0, correct? Find a coterminal angle, like example number 2 that I did. Find a coterminal angle by adding by adding or subtracting, right? Subtracting 360 as many times as needed. Remember, in example number 2 or 3, when I did that, I subtracted 360 3 times from one. The angle was 1000 something, right? I did 3 times 360, as many as needed. To get, why we are doing this? To get an angle, greater than 0 degree, but less than 360 degree. Before going to step 2, correct? Let me show it how. For example, let's say I'll use that angle f theta. I'll do it again. Here you will know it why. Theta is given 1387 degree. You see, first of all, your theta is greater than what? 360. What should I do in step 1? I should find a coterminal angle. How? I will subtract 360 as many as needed. The easy way, I told you to divide 1387 degree by what? By 360. Divide it and find that decimal number, which was 3.9 or something, right? Use this whole number. This is the number that you have to multiply it with what? 360 and subtract with 1387. Correct? It means I'll go this way. 1387 degree minus 3 times 360, which gives me 1387 degree minus 8. 3 times 0 is 0, 3 times 6 is 18, 3 times 3 is 9, 10, right? 1080. And if I subtract, it gives me 7 minus 0 is 7, 8 minus 8 is 0, and 3 minus 0 is 3, 307. That is coterminal. Coterminal angle for which angle? 1387. That's your step 1. I put notes here for you. I show it in a numeric example. What is step 1? Actually, I'm doing example number 2 again, step by step for you, with putting notes. Correct? After you did this, step number 2. In step number 2, find the reference angle theta prime. Reference angle for what? for this angle, 307. And I give you 4 rules. 307 lies in quadrant number 4. All of us, we know that. What was the rule at quadrant 4? Theta prime equals 360 minus theta, right? It means here theta prime equals 360 minus 307, which your theta prime is 53, am I right? Yeah, 53 degrees. You see, this is your step 2. When I did example 2, because in your book it's in this order, maybe it was a question for you, why he's doing these stuff, but here I'm writing step by step. What should you do in step 1 if your angle is greater than 360? What should you do in step 2? Step 3, step 4, step by step. After you found the reference angle, we go to step 3. In step 3, find the trig function functions for reference angle. Reference angle, let me put the name also, theta prime. Correct? Because here I used an example that is 53 degree. It means, and this, when you come here and this step, find sine of 53 degree, cosine of 53 degree, secant of 53 degree, tangent of 53 degree, cotangent of 53 degree, and cosecant of 50 degree. Why I'm not doing it here for you? Because 50 degree is not an exact value. That's why I'm avoiding. Usually we use this topic, this method, for the angles that we already know, like for 30, 60, 45, those type of angles that we already know their 6 trig functions, we use them, not an angle like this. Instead of looking for the secant of 50 degree, you can look for the secant of 1387. It's the same if you use calculator. But if it was an angle, something that I could use 30, 60, or 45, yes, why not? Correct? I will do another example after I put the steps for you. Step number 4. Determine the correct signs, my method, you see, the correct signs for the values found in step 3. You see in which example I did that? The example before this lecture here for 210. Because it was 30 degree, I fixed the sign for this. Because I know 210 which quadrant it lies and what are the signs there, I fix the signs. correct, or correct the signs. That's the meaning of step 4. This is all. This is all. Follow these 4 steps. You can find the trig functions for non-quadrantal angles, correct? Let's do an example, show you everything. Find the exact means don't change anything to decimal, correct? Because you have to round off, then when you round off it becomes approximately. Exact means keep it as a fraction. Find the exact value of cosine of negative 240. Correct? To gives you an idea, because here this is the first example that I'm dealing with negative angle. To give you an idea, I'll draw the angle for you here. When I'm talking about negative 240, again, this is your initial side. Negative 200, you have to go clockwise, correct? To come here, it becomes 180. And if you go a little bit more, like somewhere here, this is negative 240 degree. Correct? What is the reference angle? This one, the positive one. Reference angle is always positive. X-axis, terminal side, this is your theta prime. We will see how to find it. Because if you go this way, you see you have to take your negative 240 and add how much? 360 in it. It gives you 120 positive, correct? It gives you 120, which is the coterminal, correct? To find the coterminal, you have to add 360 or subtract 360 to give you to find the coterminal. Step 1, right? I did the step 1. Here I added 360 because negative 240 is less than 0. You see, I told you at the beginning in step 1, if theta is greater than 360 or theta is less than 0, you have to first find the coterminal, which we did here. That's 120. Now, to find the reference angle for 120, correct? You do this, 180 minus 120, which gives you 60 degree. Wow, we already know your theta prime is what? 60 degree. And we already can use our table, which we did in 2.1, and write down the trig functions for 360 and fix the sign only. Correct? Then I can start like this way. Sine of negative 240 equals to sine of 60 is radical 3 over 2. But look, 60 actually is here, right? 60 is in quadrant 1 somewhere. Here's 60. But now your 60 is in quadrant 2 because it's a reference angle. What is the sign of sine in quadrant 2? Y is positive, R is positive, then the sign is positive, correct? It means sine of, oh, actually even we don't need sine for this problem. Why I found the sine? Oh, I start to find all 6 of them. They just asked for cosine. Okay, let's do the cosine then. Cosine of negative 240 should be the same as cosine of 60, which is cosine of 60 is 1/2. But you are in quadrant 2, and you know in quadrant 2 x is negative and cosine is x over r. It means fix the sign or correct the sign. Put a negative. You are done with the problem. Cosine of negative 240 is negative 1/2. Correct? A different type of examples that we can do here. Evaluate cosine of 120 degree plus 2 sine squared of 60 degree minus tangent square of 30 degree. It looks crazy. I know. It says, wow, what is this? But believe me, it's so easy. The only problem that you have is here, cosine of 120, because you don't know it, but now you know the trick, how to find the cosine of 120. 120 lies in quadrant 2. You can find the reference angle for 120. You see, quadrant 2 was theta prime equals 180 minus theta, right? That means your theta prime is equal 180 minus 120, which your theta prime will be what? 60. And cosine of 120 equals to the cosine of 60. Cosine of 60 is 1/2. But you are in quadrant 2. You should just fix the sign negative 1/2. Okay. What was sine of 60? Because you need here sine of 60 and you need the tangent of 30. You have your table from 2.1. Sine of 60 degree equals radical 3 over 2. Tangent of 30 degree, which is equal to cotangent of 60, or you can just check in your table, tangent of 30 degree is radical 3 over 3. Plug in these three values in this sentence and calculate. Instead of writing cosine of 120, you can write negative 1/2 plus 2 times sine of 60 is radical 3 over 2, but a square. All of them is square because it's sine squared. Minus, instead of tangent of 30, you can use radical 3 over 3, but because you have a square. This easy. Simplify this. Negative 1/2 plus 2 times. If you square radical 3 over 2, square cancels out the square root. 3 and 2 square is what? 4. It means 2 times 3 over 4 minus 3 over 9. Here you can simplify 1 time, 2 times. It means negative 1/2 plus 3/2 minus 3 over 9. You need a common denominator here, correct? Between 2 and 9, the common denominator is what? 18. You have to change all the denominators to 18. It means multiply here 9, multiply here 9, multiply here 9, multiply here 9, which you end up with, I'll show you all the steps, negative 9 over 18. Oh, and also multiply 2 at the end, right? 2 here, 2 here. to change that one also to 18. Plus 27 over 18 minus 6 over 18, which is equal, denominator 18, negative 9, negative 6 gives you negative 15, negative 15 and 27 gives you positive 12, right? 27 minus 15 gives you 12, positive. Now simplify by 6, which gives you 2 over what? 3, the value of this sentence. I will stop the lecture here. There are really other good examples in your book and also in your presentation, which is in Canvas. Practice with those and see you all in section 2.3.